There's a lot of ways of graphing this exponential function. One is to know what this graph looks like and then understand that for every x that you put in, adding a 1 over here simply makes the y 1 higher. So if you know what the graph of this looks like, say it looks something like that, if you go to every single point and make it 1 higher, the new graph, this one, will be the old graph shifted up 1 vertically. That's useful, but at the beginning, it's also pretty useful to get good at a table of values. So let's try graphing this thing by making a table of values. There's some useful information to be had here. So let's start maybe down here with 0, because 0 is pretty easy. We get y equals 2 to the 0 plus 1. 2 to the 0 is 1, so we have y equals 2. So we have the point 0, 2, and that is called the y-intercept. Now if we put in a 1, we get 2 to the first plus 1, and that's 3. So when we put in 1, we're getting something that is 3 high. When we put in 2, 2 to the second plus 1 is 4 plus 1, and that's 5. So when we put in 2, the thing is going up to 5, and let's try 3. When we put in 3, 2 to the third is 8, 8 plus 1 is 9. So when we put in 3, 6, 7, 8, 9, it goes up here and we can see that exponential increase. It's really going up faster and faster. It looks kind of like the right-hand side of a parabola, but it's not. Now what happens if we put in -1 here? Well, that's worth writing down. We get y equals 2 to the -1 plus 1. 2 to the -1 means the reciprocal of 2. That's 1/2 plus 1. Y equals 1 1/2. So when you put in -1, you get 1 1/2. What happens if you put in -2? Well, you'll get y equals 2 to the -2 power plus 1. Y equals 1 on top of 2 to the second power plus 1. Y equals 1/4 plus 1. Y equals 1 1/4. So here we get 1 1/4, and in fact, as x gets more and more negative, -3, -4, -1,000,000, this gets closer and closer and closer to 0, and 0 plus 1 is 1, and so this thing is getting closer and closer and closer to 1, but it never quite touches 1, and this is a pretty good graph for this function. Let's see what Desmos has to say. And you can see we have the right y-intercept. We have some correct points. We see that as it comes out to the left, those negative powers of 2 get closer and closer and closer to 0. So when we add 1, they're getting closer and closer to 1, but it never quite touches 1, although visually it looks like it does. But if we expand on it, do you see that it's always a little bit above 1, no matter how far you go? Now, I've gone far enough that it looks like it's hit it again, but if I expand it, it's always a little bit over. That idea of it approaching 1 forever, but never quite getting there, that's an important idea. Now, I've kind of lost myself, so there we go. I'm back again. Desmos is kind of interesting to play with. Again, if you know what the graph of this function looks like, then the graph of this function will move this graph, instead of up 1 like on the very last problem we did, it's going to move it right 3. Now how do we know it's going to move it right 3? Well, I'm telling you it's going to move it right 3. But also 3 is the x value that makes this exponent 0. Positive 3 makes this exponent 0, and that positive 3 means right 3, because when x is positive, x is measured on the horizontal number line, and that plus 3 means right 3. However, that's useful information, but right now in our progress on this, boy, do we need to put in numbers and find out what's going on. So let's put in 3 for x, and then we get 2 to the 0 power, which is 1. Let's put in 4 for x. We get 2 to the first power, which is 2. When we put in 5 for x, we get 2 squared, which is 4. If we were to put in 6, we would get 2 to the third, which is 8. Now let's try putting in 2 for x, and let's slow down. Because we get 2 to the negative 1 power, which is 1/2. And when we put in 1 for x, we get 2 to the negative 2 power, which is 1/4. And one more, if we were to put in 0 for x, we get 2 to the negative 3rd power, which is 1/8. And so when we're asked to sketch the graph, when we put in 3 for x, we get 1. When we put in 4 for x, we get 2. When we put in 5 for x, we get 4. I'm not going to do 8 on this sketch. When we put in 2, we get 1/2. When we put in 1, we get 1/4. When we put in 0, we get 1/8. And again, it looks like that exponential growth, but here it looks like we're approaching the x-axis. We're getting closer and closer and closer. This is actually called an asymptote, but we don't need to know that name yet. But we have this graph. Let's look at what Desmos has to say about this. And we can see the elements of this exponential graph. As it goes to the right, it climbs high pretty fast. Now, one thing that I haven't mentioned is sometimes when you zoom out, you get a bigger picture that's slightly different. Look what happens when I zoom out. When I say this thing starts to grow really fast, look, it really does grow really fast. I mean, it almost looks like it's vertical when you zoom out and get the big picture. It used to be when folks didn't have software like this, they always pictured an exponential equation something like this, and the teacher would say, well, as it goes to the right, it climbs higher and higher. But they didn't really see what that meant. Now you guys can see what it means, and as you go to the left, it gets closer and closer to the 0, the x-axis. But it doesn't really get there ever. Those are important ideas. So eventually we might be able to get a few ideas about what this graph looks like just by looking and thinking and using some stuff that we've memorized. But for now, let's do an accurate table of values and see what happens. When I put in x equals 0, I'm kind of curious. I get y equals 1/4 to the 0 power, and that's 1. So I'm going to keep score over here. When x is 0, y is 1. That looks like this point right here. When I put in x equals 1, I get y equals 1/4 to the first power, which is 1/4. So that wasn't quite as exciting. When I put in x equals 1, I get a height down here smaller than 1/2. It's at 1/4. I'm going to do one more against my better judgment. When I put in a 2, I get 1/16. So that's almost at 0. So this thing's coming in and getting closer and closer to 0. It's not going way high when we go to the right. It's approaching 0 when we go to the right. So what I'm thinking is it's going to go way high. This is a guess. I'm thinking it's going to go way high when we go to the left. In other words, having this base be 1/4 seems to flip the thing around the y-axis. It seems to turn it around for some reason. But let's check it out. Let's put in a -1. So now we have y equals 1/4 to the -1 power. A -1 power means reciprocal. So that's y equals 4. So when we put in -1, this thing should be at 4. Yeah, it's not only climbing high, it's climbing high really, really fast. Let's try one more. We have y equals 1/4 to the negative 2 power. This says take the reciprocal and square it. So we take the reciprocal and we square it, and that's 16. And when this is 2, this is 16, and it's off my graph. This is going really, 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 really steep, really fast. So let's check this sketch out in Desmos and see if we've got it right. It looks like we have it correct. Again, instead of philosophizing, we're going to make a table of values. And so I'm going to put in 0 here for y, and we get 3 to the 0, we get 1 for x. I'm going to keep score over here. So when x is 1, y is 0, and we have this point right here. When I put in 1 for y, I get x equals 3 to the negative 1. That's the reciprocal, which is 1/3. So when x is 1/3, y is 1. I want to go to y equals negative 1, so that'll be x equals 3 to the minus negative 1 power. That's 3 to the first power. That's 3. So when x is 3, y is negative 1. Let's try 4. No, let's not try 4. 4 is ridiculous. Let's try negative 2. So we have x equals 3 to the minus negative 2. That's 3 to the second. That's 9. So we have 9, 4, 5, 6, 7, 8, 9. Negative 2. We're just sketching. Seems like it's going this way. So if this is an exponential, what do you think is going to happen over here when we go this way? Well, don't know. Let's try y equals 2 and find out when y equals 2 what x is. So we get x equals 3 to the negative 2. That's 1/9. It's 1/3 squared. So when x is 1/9, we're at 2. And so on and so forth. So it looks maybe like this is happening. It's approaching here, and then it's shooting out to the right pretty fast. This is kind of like one of those exponential graphs turned around. Remember we had some that looked like this? Well, if you rotate this 90 degrees to the right, if you turn it, it'll look like this. So that's the net effect. Let's check in Desmos. And we can see that we were correct. We had it pretty much correct. It is kind of that exponential equation turned sideways. And that's what the interchanging of x and y do. Now this is extra, so you don't have to understand this. But going back to our work on inverses, let's just take a look at this. I'm going to put in what I think might be the inverse, maybe. And let's just see if it is. This is guesswork, and as such, it might very well be wrong. And then let's plot y equals x, because that inverses are always symmetric about y equals x. So do you see some symmetry here? Are those possibly inverses? Well, they might be. We don't really know, but we suspect.